So why should we worry about carbon dioxide anyway? Well, the nature of the physical nature of the molecule allows it to have incoming shorter wavelength radiation pass right through it, but absorb the outgoing re-radiated heat energy, the infrared energy from Earth's land and water surfaces. The physical construct of the molecule is such that it has this physical property. And it makes logical sense then that if you have Earth's gaseous envelope that contains carbon dioxide, and we increase the amount of carbon dioxide, the amount of this heat-trapping gas in this envelope, that the temperature of the overall gassy envelope will rise. And that hypothesis has been examined extensively for the last 2.5, 3 decades, and we have a consensus opinion all over the world in terms of the scientific community about what's happening. So we're worried about this because if this gaseous envelope is warming up, the natural as well as anthropogenic, that is man-based or man-made systems on Earth are going to be affected. So governments and scientists are worried about this heat increase in our atmosphere and some of the repercussions. And some of the repercussions could be increased and more droughts. It could be something in regards to the stability of existing plant and animal habitats. Are they stable? Are they not? What will happen if our planet warms up and these become changing or dynamic variables? Are we going to have enough food? And is that food production going to be able to keep pace with our growing population? What about coastal cities? Since millions of people live on the coasts, are these safe? And if they're subject to change, are we going to be ready for that? We're also worried about wetlands as sea levels rise, these wetlands that buffer cities from the worst of meteorological effects such as hurricanes. Are they going to be disappearing? And if so, are we going to be ready for that? We're also worried about the spread of infectious diseases because as climate changes, disease vectors also change. We're worried about natural resources and the conflicts that may ensue if climate changes to the effect that people then feel the need to exercise some kind of force in order to ensure their continued access to natural resources. And also, of course, we're worried about refugees in regards to climate. These are climate refugees. We're not seeing that in places like Illinois now, but we are seeing climate refugees in places like the Maldives and or the coastline areas of low-lying places in Alaska, where indigenous people in Alaska and in the Maldives and low-lying coastal areas all around the world are now feeling the first effects of climate in terms of their livelihood and habitat. So the organization that tracks this, that speaks to the world, that clarifies scientific opinion, is called the Intergovernmental Panel on Climate Change. And most people just refer to this as the IPCC. This organization was established in 1988 by the World Meteorological Organization and the United Nations Environment Program. They got together because there was not a lot of good knowledge in the mid-1980s about the current state of climate research. So the mandate then of the IPCC is to provide the world with a clear scientific view on the current state of knowledge in climate change and its potential environmental and socioeconomic impacts. So the mandate is basically to clarify the scientific consensus about this issue. And as a result of that, in the ensuing decades, thousands of scientists around the world have contributed to the various assessment reports that the IPCC publishes. We are currently now looking at the 5th assessment report, and that's oftentimes just referred to as AR5, Assessment Report Number 5. So the IPCC then has 3 working groups that assess and interpret peer-reviewed scientific papers that appear in professional journals. Now, before we go on, we should take a little time to kind of understand this idea of peer-reviewed scientific papers in professional journals. If you're a scientist, the intent of your profession is to conduct studies to test a hypothesis that you may have, and your studies then are either going to support or refute your hypothesis. You then go through an arduous process of conceiving of a study, conducting the study, and then, very importantly, publishing your findings. Your published findings are then sent to one of dozens of peer-reviewed professional journals. These journals then will publish papers only if your peers say it ought to be published. So a journal will then say, receive a paper for publication. An author's name and any identifying factors will be omitted, and then that paper will be sent out for review. Usually it goes to about 3 different scientists, and these scientists are experts in their field. The scientists that examine these papers do it on a voluntary basis, and they then recommend to the editor of the journal if a paper ought to be published with changes, or rejected. So that then recommendation goes back to the editor, and the editor informs the scientist of what the peer decision is. The reason this long, arduous process takes place is because it's the backbone of science. That is, we want as rigorous of studies as possible, and the only way we can do that is to have a very aggressive evaluation process that's free of all bias in terms of who knows who and what the current political climate might be at one school versus another kind of institute. So we have then the IPCC only working with peer-reviewed scientific papers in professional journals, and the IPCC then has 3 main working groups. Each working group looks only at these kinds of papers. The first group is the physical science group. They're looking at basically the science of climate change. The second group looks at the impacts, adaptation, and vulnerability coupled with climate change. And the third group looks at the mitigation of climate change. These 3 groups publish their own particular portion of an assessment report, and they come out at slightly different times. The graphs that you'll see in this presentation are all about the physical science of climate change, and not the other 2 working groups. Lastly, about the IPCC, it's important to understand that the IPCC does not conduct its own research. All the IPCC does is take published peer-reviewed scientific papers and assess them. And you remember their job, it's to provide the world with a clear scientific view on the current state of knowledge. Now, the reason this happens is because an average person around the planet, if they picked up a scientific journal about meteorology, they would have no idea how to interpret it. It's written in the language of science, which most of the time you have to have a master's or a PhD to understand, and many years of work in order to understand what goes on in terms of creating the study, the math that goes behind it, and the procedures that go within it, and all these different variables. So it's basically opaque to the average person. And so the IPCC's job is to provide the world with a clear view of the scientific community's understanding, because as good as scientists are at conducting studies and communicating within their own group, they may not be as effective as they could be in terms of communicating with the general public. And that's where the IPCC is basically the bridge. They take otherwise opaque scientific research and make it digestible for the public. And their particular audience are policymakers. And policymakers are basically lawmakers. So people that draft laws, particularly climate treaties, need to know what the current state of science is. And so the IPCC serves that purpose. They provide policymakers with a clear view of the scientific consensus of climate change. They serve as a kind of a bridge. So AR5 has these main points plucked right out of their policy summary. We have then several points here that we can examine. So we have Earth's climate is warming, snow and ice is diminishing, and sea level is rising. And remember, this is the current state of understanding in climate research. The last 3 decades have been warmer than any preceding decade since 1850. Earth's oceans have stored 90% of the increased energy accumulated between 1971 and 2010. Essentially, the oceans are warming up. Greenland and Antarctic ice sheets are losing mass. This is measurable, which is sort of surprising when you think of an entire continent's ice being able to be massed, but we have that technology now. Between 1901 and 2010, sea level rose 0.19 meters. That's almost 1/5 of a meter, and that's considerable, right? Atmospheric carbon dioxide concentration has increased 40% since the Industrial Revolution. The largest contribution to Earth's warming is increased atmospheric carbon dioxide. This is important because although there are other very powerful heat-trapping gases, we have carbon dioxide being the most important one, mostly because there's such a large volume of it. And finally, it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. This is a very important point because for many years there was some confusion and or debate and or kind of wondering, well, maybe this climate change, this increased observed heating is natural, and scientists have looked at that. The scientific consensus now is that it's human influence that is causing this observed warming since the mid-20th century. It's not some natural cyclical cycle that the Earth is passing through. We're going to look at that in particular in some graphs that are coming up later in the presentation, where we look at computer models that ask, well, if this is a natural and or natural and man-made phenomena. And so that's coming up along with lots of other graphics that were plucked right out of the AR5.